If the romantic comedy was the internet, like it was, I wanted to importantly.
Okay, so what we have here is we have a piece that's bent right here. I think someone has their maybe it's AC. Someone has maybe mute themselves. I can hear a TV in the background or something. Okay, so we have a piece here that's 2 inches wide, and it has a bend right here of 130 degrees. So we're going to do the calculations like we've been doing to all the other bends. The only tricky one is this one is bent more than 90 degrees. So I think we left off with Sam number 1 on the last one. So Sam number 2, we got our little list down here. So what material, and you can pick, what material is this going to be made out of?
Just go with 2024 T3.
Okay, 2024 T3, I'm fine with that. Joe, what thickness do you want this to be?
Um, 0.32. Oh, 32.
Okay, so we'll make it 32 thousandths. And Lake, using the chart on page 4-62, what would the minimum radius be for this piece?
.12.
Yeah. So according to the chart that's in the AC 4313, also in our textbook, also in your little handbooks, the minimum radius would be 0.12, which is basically an eighth. So when I see 0.12, I just think of an eighth. So that's our minimum radius, Lake. What radius do you want to use for this part? So 0.12 is the minimum. What radius do you want to use? Lake, can you hear me?
I don't know.
Well, we know that 0.12 is the minimum, so pick a radius that you want to use. I mean, you can use, we know what the minimum radius is, so you get to pick what radius you want to use. And don't forget, I'm recording this. And it's, what's that?
Can't we just use 0.12?
We can. It's up to you. I'm asking what you want to use.
Yeah, I guess that.
Okay, so we're going to use 0.12. So that's the minimum radius, and that's the radius we're going to use. So, AC, what is our formula for the setback now? Now that it's not a 90-degree bend, what is our formula for setback going to be?
It's K times the sum of R plus T.
Right, K times radius plus thickness. Now, AC, based on the chart that's in the book, how many degrees is our bend?
It's a 50-degree bend.
No, because remember it started flat and then we bent it. We bent it over 90, you know, we bent it to 90 and then we bent it further than 90.
Okay, it's 130. I
So
wasn't
it's
sure.
130 degree bend. I didn't try to trick you this time. The last time I tried to trick you. But this time it's a straight 130 degree bend. So what is the K value for a 130 degree bend?
It's 2.144.
Right, 2.144. That's the K value. And the radius is what?
It's 0.12.
0.12. And then the thickness is what?
0.032.
Right. So I'll let you, I'm sure you have a calculator there. Using PEMDAS, we're gonna do the radius plus the thickness first, and what do you get there?
0.152.
0.152. And we're gonna multiply that by the K value, right?
Correct.
And what will that give us? So we'll do 2.144 times 0.152, and what do we get for an answer?
0.326.
0.326. So if I come over here, what will our setback be?
Oh, 0.326.
326. Perfect. Good job. So now we know our setback. We use the K value times the sum of the radius and the thickness. So I can erase all this now, because now we know our setback. Nate, you're next. What do we want to figure out? What do we want to figure out next?
We're gonna look for a flat one.
Sure, flat one. I'm cool with doing, we could really do them in either order, right? There's no reason we couldn't do them in either order, but we might as well just flow. So what would the measurement of flat one be?
So it's gonna be 2 minus our setback, which is 326 thousandths.
Correct.
Let me just grab my calculator. It's just right up here.
Sure, no problem.
$1.67.
Sure. 1.674 would be our measurement of flat one. And then, Cody, what would be the next thing we want to do? What's the next thing we need to do? We're just going down the line here of all the stuff that we need to figure out.
Were you asking me again, Mark?
No, this is for Cody. And don't forget, guys, this will probably end up on YouTube, so, because I'm recording it. So tell me what we want to do, Cody. Let's walk through this. What do we want to find out next? What's the next logical thing to find out? I think you're muted. You need to unmute yourself if you're talking. What's the next logical thing we want to figure out?
Try to find flat 2.
Sure, we need to find the measurement of flat 2. So basically, what's going to be our step? How long is flat 2? On our blueprint, how long is flat 2?
4 inches.
4 inches. So we need to subtract what from that 4 inches?
Uh, SB.
And SB stands for what?
Trying to remember again.
Set.
Set. Set bend.
Set close. Set back.
Setback.
Setback.
And
Right.
then
So it's
then
not.
you,
It's not ready, set, go. It's not bump, set, spike. It's set back, right? Setback. So we take the 4 inches, we subtract our setback, which is here. And Corey, what do you get if we do that math? If we take our blueprint 4-inch section here on flat 2 and then subtract the setback, what do you get?
Get 3.678.
3.678.
Yeah.
Try it again. So we
Hold
take
on.
4 inches and we subtract 1 setback.
1 setback. Isn't setback 0.326?
It is.
Oh wait. Subtract. You'd subtract 2, right? Or no, 4.
4, because this is 4 inches. Our blueprint dimension is 4 inches.
Yep.
And we're going to subtract 1 setback, which is 0.326. So what's
Yep.
that going to give us?
4 minus 0.326.
4 minus 0.326.
Yeah, that's 3.674.
Correct. You said 0.678 the first time. So I just wanted to make sure we're all on the same page.
Oh, okay. Wrong. I read the wrong one. My
No,
bad.
that's all right. But I just wanted to make sure we were all. I did it in my head, so I just wanted to make sure I didn't screw up. So,
Okay.
Jake, you're next. What's the next thing we want to figure out?
The total length.
Yeah, but we can't do that yet. There's still one more thing we need to figure out before we can do that.
Yeah, sorry, bend allowance. Yeah, fine.
Bend allowance. So what's the easiest way? There is a long formula. There's a long formula to figure out bend allowance. What's an easier way to figure out bend allowance?
Look at the chart on 4-66.
Yep, page 4-66 of the FA 8083 Aviation Maintenance Technician Handbook, Airframe, Volume 1, page 4-66 has a nice chart. So if you look at that chart, what do you get for a bend allowance?
I get 0.218.
Okay, and you're not entirely wrong. You're not entirely wrong at all, but 0.218 would be the bend allowance if
Oh, if it
that
was
bend
90.
was how many degrees?
90 degrees.
Would be 90. Our bend is how many degrees?
130.
Our bend is 130 degrees. So
You gotta use that bottom number.
we got to use that bottom number. So what is that bottom number?
0.002427.
0.02427. 427. Okay, that is the bend allowance number per degree. So we're going to have to take that really, really small number and we're going to have to multiply it by what? Because that's the number per degree according to the chart.
Would you multiply it by 130?
We would take that number and we would multiply it by 130 because that's how many degrees this is bent. So if you have a calculator there, I don't have a calculator here, but if you have a calculator, what do you get when you multiply that really, really small number by 130?
I got 0.315.
0.315. And just by the number, I'm not double checking your math, but that number seems right to me. So 0.315 is what you get. Quinn, then what is that number going to do for us? 0.315, what do we want to do with that number? What does 0.315 become?
With the bend allowance?
That becomes our bend allowance. So we use that formula. So now we know our bend allowance is 315. So AC, now that we have all these figures, we have them all listed nice and neat here. So now we know what the figures are. So let's start making our blueprint of our flat sheet. So AC, what would you want to do first in making our blueprint?
Well, I'd want to get my bend allowance marked off.
Okay, you want to do the bend allowance? So that would be right here, right?
Yep.
And what would our bend allowance be?
0.315.
0.315. I agree. Okay. Jesse, what would you want to do next then?
I would label flat 1, the length of it.
Okay, flat 1. So flat 1 is here. And what would the length of flat 1 be?
1.674 inches.
1.674. I agree with that. So now we got those two labeled. Eric, what would you want to do as the next step then?
Oh, sorry, I was still muted. For labels, I would want to label flat 2.
Flat 2. And what is the measurement of flat 2?
3.674.
Perfect. So now we have flat 1 labeled, we have our bend allowance labeled, and we have our flat 2 labeled. So then, Mark, what's the next thing we want to do?
The total length.
Total length. And I don't have a calculator. If you have a calculator, what would be the total length? First of all, how are you going to figure out total length, and then what would the number be?
They are all add flat 1, flat 2, and setback together. I mean,
Not setback, close. You were really close. You're right. We would take flat 1, we would add flat 2 to that, and we would also add what?
bend allowance.
Bend allowance, which again, the bend allowance is that part right there.
Yep.
Okay, so what would the total be if we take flat 1, this bend allowance, and then flat 2? What would that total figure be?
5.663.
5 point what?
663.
663.
Yep.
Okay, that sure. I'll agree with that. If anyone disagrees with that number, let me know, but I guess it looks like it's okay. So then, Matt, now we have that. What's the last thing, what's kind of the last step we need to do before we, well, let's say now we could go ahead and we could go to the shear, we could cut out a piece of aluminum that is what dimension? We could cut out a rectangle that is what?
2 inches wide.
2 inches wide. By what?
2 by 5.663.
Right. So we would cut out that piece of aluminum. Then we would draw these bend tangent lines. We would draw these bend tangent lines here. In between those two bend tangent lines would be our bend allowance. Then what's the next thing we have to draw on our piece of aluminum here?
The sight line.
We have to draw the sight line. So what we want to do is, do you remember what the first step that I taught you how to do is? You want to figure out, with regards to the brake, you want to figure out what? It's really important to know what that you're going to put into the brake.
Oh, you need to figure out which Shim.
No, well, we would know since we picked, because we know our break, and we picked a radius of 1/8 of an inch. So we would know to use the shim in our break that'll put 1/8 of an inch radius. So yes, we do need to know what shim to put in. But as far as marking on our piece here, what do we need to know about, put it this way, how do we need to mark it so we know which end to put into the break?
We have to put the sight line on the outside of the radius.
Well, no, but before we do that, and maybe I'm not asking the question, what we always need to do is just know which end of our piece we're going to stick in the break.
Oh,
What I do is I just put an X. I just put an X on one of the ends. So now I know that when I go to bend this, I'm going to stick this end that has flat 1. That's the end I'm going to stick into the break. So Gabe, I'll go to you. So now we're going to need, Matt told us we need to write our sight line in here, and I agree we do need to put our sight line. How are we going to know where to draw our sight line?
It would be off of the side that you're going to stick into the press.
So we're going to measure from this bend tangent line right here?
Yes.
Okay, and what, how much are we going to measure?
Isn't it the radius?
It is the radius. So our radius is 0.12. So we're going to measure 0.12 from this bend tangent line. And then we're going to draw our sight line like right here.
Other way.
Other way. So like right about, I mean, I'm not, probably like about like that, would you say? Is that a close representation?
Somewhere in there.
Somewhere in there. Because we know that this distance is 0.315. So 0.12 just roughly would be 1/3 of the way, right? So I agree. So we would draw our sight line. We would draw our sight line there. Then we would go to our break. I'm gonna erase this stuff for the bend allowance because we already figured that out. So now we have our break. Here's the nose of our break. We're gonna put one shim in there. We're gonna put one shim in there so that we get a 1/8 of an inch radius. Then we're gonna put our piece of aluminum in there. I'm not drawing very straight lines, but you guys get the picture. This is flat 1. This is flat 1 that's in there. Noah, this bend tangent line right here would be where in relation to our break here?
Just under the nose.
So like maybe right about here?
Yeah, maybe even a little bit more in, but yeah.
Okay, so right about here. I agree. So that bend tangent line would be right about there. John, where would this bend tangent line be?
That would be to the right of that shim.
So probably right about here?
Maybe a little further, but yeah, somewhere on that side.
Like here?
Yeah.
Okay, I agree. You know, roughly. I mean, we're not doing it exact. We're just trying to give a decent representation. So I'd say yeah, right about there. Then, Michael, where would our sight line be?
Like right under the break where you can just see it if you're looking over it with your eyes.
Right about where my pencil is now, maybe?
Yeah.
Yeah, so it's not to scale, but I would say, yeah, our sight line would be right about there because if we had our eyeball here, so let's say here's our eyeball, there's our little pupil right there, you know, there's our thing, here's our nose, and then our lips. I'm a very good drawer. There's our chin, right? Here's our forehead. You know, we'll put a nice head of hair on here. So when we're looking straight down from our eyeball and looking straight down,
Looks like Cody.
we should, that looks like Cody. I think it looks just like Cody. I think it's a, I
Looks
think
like
it's a good
Frankenstein.
drawing. So when we're looking straight down, we should look right at the nose of our shim, and we should line our sight line up right on there. Then we can lock it down. We can lock it down, and then we can bend it. Does that make sense to everybody?
Yes.
Okay, good. I am gonna stop recording if I can figure out how to do it.
Make sure to